The galaxy was quiet. It was a heavy, deep kind of quiet, the kind that sits on empty space like a thick blanket, where nothing moves and nothing speaks, and even the light seems afraid to show its face. In that silence, a cold cloud drifted for ages, a wide and ancient cloud made of dust and gas, slow like a winter river, thin as breath. And it had no name yet because there was no one to name it. It was the cloud that would one day be called the Solar Nebula, and it did not know anything, and it did not plan anything. And still it carried the first pieces of a long story inside it. The cloud was not alone in the dark. Far away, but not too far, a star was dying the way great stars die, with a heart that had grown heavy and a skin that could not hold the pressure anymore. And the last calm seconds of that star stretched long, and then they snapped. The star tore itself open. It exploded in a supernova, and the light was not just bright, it was terrible. It was like a shout that could be heard with eyes, if eyes had been there to see. The blast threw a shockwave through the dark, a ringing wall of force and wind that raced across the quiet like a storm without rain, and it carried new things with it too. Heavy elements made in the final fire of the dying star. Iron and nickel and gold and more. Small grains and ions and fragments that rushed out like seeds. From a broken pod, the shock wave hit the drifting cloud. It did not ask. It pushed. It squeezed. It wrapped the cloud in pressure and made the thin gas gather and thicken in places. And strange lights flickered where the squeeze was strongest, as if the dark had caught tiny sparks and was trying to hide them but could not. The wide body of the cloud shivered, and long arms of gas began to curl. The dust swam toward the heaviest spots in slow, steady rivers, because gravity was always there, visible and patient, pulling even when nothing else seemed to move. Inside the cloud, most of the gas was hydrogen and helium, the simplest things in the universe. Hydrogen is a small word for a very simple atom, one proton and one electron, light as air and lighter than thought, and helium is two of each. And they do not stick to other atoms easily. They mind their own business, but even they will surrender when gravity leans on them long enough and hard enough. So the hydrogen and helium began to compress. The pressure rose in little knots that grew into lumps and then into cores. And the temperature climbed because when gas gets squeezed, it heats up, and the cloud that had been calm for so long was calm no more. Something else began to change too. When the shockwave passed, it did not just squeeze. It gave the cloud a small twist. It was a tiny spin at first, just a hint, but in space, a hint is enough, and time is long. And the twist grew stronger because as the cloud collapsed, it had less room to spread, and the spin had nowhere to go, so the cloud turned faster. The way a skater spins faster when arms are pulled in. The cloud flattened into a wide, thin disk, broad like a plate and glowing at the warmest places. And dust and ice and gas moved inside that disk like cars in a slow circle around a city square. Anyone had stood far away to watch, they would have seen a strange flat storm, soft and bright at the edges, hot and fierce toward the center. Now they would have felt the pull of it even where they stood. Now the story narrowed. In the center of the disk, the pressure grew like a held breath, and the heat rose like a tide. Hydrogen atoms that had floated in peace for billions of years found themselves pushed together so tightly that they began to touch in ways they never had before, and that kind of touch is not gentle. It is the beginning of fire. But the fire had not started yet. It was a promise, a soon, a not quite. The center was a thick knot, a core of gas so dense it acted like a star, but without a star's heart. This was a protostar, a before star, and it was like a candle, wick soaked in fuel, waiting for the spark that would change everything around the protostar. The disk whispered and roared at the same time. Fine grains of dust bumped and stuck, pulled by static and brushed by gentle chemistry, and tiny clumps became pebbles, and pebbles became stones, and stones became boulders, and the boulders drifted in wide tracks that cut faint paths through the gas. But those were small stories for later. The biggest story was still the center, because gravity had no mercy there. Every second, more gas fell inward. Every second, the core grew heavier. Every second, the temperature rose another notch. 10,000 degrees, 100,000, a million. And the pressure was so great that the atoms themselves seemed to cry out. The disk kept spinning. The edges threw off waves, and invisible magnetic lines curved like harp strings through the gas, plucking streams of matter into thin jets that burst from the north and south of the core and shot into space, carving dark lines in the light like scratches on glass. He watched nothing. She watched nothing, because there was no he and no she yet. Only forces older than names. But if a human eye could have looked into that center, it would have seen a pulsing glow. It would have felt the heat on skin that did not exist. It would have understood the risk, that everything might fail. A protostar can still fall apart. A sudden gust of turbulence can tear the core. A rush of angular momentum can fling gas away. The disk can rip, and the center can cool, and the whole attempt can end in another dark cloud that drifts for more ages with nothing born from it. That fear lived in the physics of the place, even if fear had no mouth to speak. The shockwave from the dead star was not finished with its work either. It had pressed heavy elements into the cloud, and some of those heavy atoms sank into the center with the hydrogen and helium. They were few, yes, but they mattered, because they could radiate heat away better than hydrogen could. And that let the core collapse even more, tightening the knot, raising the temperature faster, driving the pressure higher, a feedback with teeth. The core shrank to the size of a small orbit, then the size of a giant planet, then the size of a star's infant body. And by then the surrounding disk sang with motion, and the inner rim glowed white and blue, and the outer rim glowed red and orange, and the whole thing spun like a coin that refuses to fall flat. The first clear sign came quietly. Deep in the core, atoms began to move so fast that their electrons could not keep them apart. Nuclei rattled against nuclei. Two protons met in a cage of pressure, strong enough to hold them together when they should have pushed away, and a chain began that turned hydrogen into something new. The reaction was small at first, a whisper of fusion, a fire behind the fire. But even a whisper of fusion is a thing to fear and a thing to love, because it means light that makes more light, and heat that makes more heat, and a future that looks like a star. But the core did not roar yet. It quivered. It blinked. The light swelled, fell back, swelled again, like a heartbeat learning its rhythm for the first time. The jets above and below grew narrow and bright. Shock fronts rippled outward along the disk, herding gas into rings, breaking the rings, making new ones, and the glowing rim threw off arcs like sparks from an iron wheel. The protostar caught its breath and held it, and then let it go in a long sigh that shook the inner disk. The sigh was radiation, photons trying to escape. The first cough of a star that did not know how to breathe yet. Out on the disk, dust felt. That cough! The grains warmed, and their ices softened, and sticky coatings formed on their surfaces. So when they touched another grain, they held on longer. The big grains grew faster in the warm ring just beyond the inner scorch, and the ring thickened and thickened again. And the disk began to carry memory, lines of density like grooves on a record, a map that said where things had already tried to be born. Farther out, where it was colder and darker, ice crystals grew like fragile flowers, and then were swept inward by drag. And the inner regions drank that water like a thirsty mouth drinks rain, and still the center pulled. Always pulled, never full. Time passed in slow storms. The protostar brightened by degrees, and every new degree set off echoes. Gas collapsing here, eddies shearing there, dust rising into loops like smoke rings, and all of it fed the center in a feast that was patient and endless. Gravity did not hurry, and it did not stop. The core shrank until the pressure could no longer be called a number that meant anything. It was simply pressure, the weight of a mountain on a pin, the weight of a planet in a teacup, and inside that pressure, the hydrogen remembered the rules. It had always followed in the hearts of other stars, and it followed them again now. The flicker came when no one expected it, which is to say it came exactly when the math said it must. A burst of light pushed through the heavy gas. And another followed, and another, and they were not the random flares of a collapsing cloud anymore. They were pulses from a core that had crossed a line. Fusion had started full and steady. Protons were meeting, turning into helium through steps as quick as whispers, releasing energy at each step. And the energy spread outward as heat and as light and as pressure that pushed back against the fall of gas. Hydrostatic equilibrium, the wise would call it much later, the balance between falling in and blowing out, the balance that makes a real star. But the balance did not slide smoothly into place. For long moments it trembled. In some layers the heat ran too fast and made the gas expand and cool and stall the reactions. In other layers the flow of matter fell too hard and smothered the light for a breath, and the new start tube flickered. Bright, then dim, then bright again, a lantern in a deep cave where the wind can still surprise the flame. That flicker reached the disk, and the disk answered with waves that ran to the edges and back. And the edges shed a faint halo that would one day be seen by creatures with telescopes in gentle hands. The supernova's old shockwave, now thin and spent, continued on into the dark, and its work here was done. In its wake, the nameless cloud had changed its fate. It had become a birthplace. The center was no longer only a promise. It was a beginning. The protostar pulsed a final uneven beat, and then steadied into a glow that did not fade when the disk's shadows passed over it. It was still hidden inside layers of gas, still wrapped in swaddling coils that would take time to thin, but it was alive in the way a star is alive. Its real name would be Sun, much later, when tongues learned to speak and minds learned to remember. But right now, it was only a heart that had started to beat. Around that young heart, the disk kept turning. Beside it, there were paths where worlds would one day walk. And in those paths, tiny bodies were already gathering like whispers before words. The light from the center reached them in warm breaths that pushed on their orbits and cooked their skins and told them, without words, what would be safe and what would be hot and what would be cold, and where water could survive. The inner rings were dry and angry and full of rock. The outer rings were soft and full of ice. Between them, there was a line that would matter very much later. But those are other chapters. The chapter now is about the first spark and the first sound in a silent universe. It is about a supernova that died loudly so that another fire could live quietly. It is about a cloud that drifted for as long as numbers can count, and then learned to fall and spin and glow. It is about hydrogen, the simplest thing, learning to hold hands and become something new. Wow. It is about pressure that could crush mountains, that do not exist, and heat that could melt anything that might one day be. It is about a light that had not been there and now was there, and once there, it did not want to leave. In the last slow minutes of this part of the story, the protostar's jets, thin and sharp, traced pale lines far into the dark, like spears thrown by a quiet giant. The lines faded, but the memory of them stayed, and the disk settled into a rhythm like breath. The glow at the center was steady now, not the steady of an old star, but the steady of a child learning to stand. If the viewer could linger in the shadow of a grain of dust and look up, the viewer would see a round brightness through layers of drifting smoke, and it would look a little like a dawn seen through fog over a cold lake. The question rose in that light, as surely as heat rises from a flame, was this the first spark that would one day create Earth? The answer did not speak, because answers in space do not speak, they unfold. But anyone who watched would feel the answer anyway. Not with ears, not with eyes, but with the hush that comes when something immense has begun. The protostar flickered once more, not with weakness, but with decision, and held its glow. The center had turned a corner. The fire inside would not stop now, would only learn to burn cleaner and brighter. Gas continued to rain inward, but now the newborn star pushed back, and the push carved a narrow bubble around it, a small, clear sphere in the fog where the light ran free and the truth could be seen. In that bubble, the first sign of the sun lived, and the darkness around it, the disk, and the night beyond the disk, leaned closer. listening. The silence of space had been broken once, when a star died and its shock wave struck a drifting cloud. But now, inside that cloud, something else stirred a second silence, a silence before a storm. The storm was not of thunder or rain, but of fire. At the center of the great disk of dust and gas, the pressure climbed higher, the heat pushed harder, and the core, that had been nothing more than a thick knot of hydrogen and helium, began to transform. For millions of years, the disk spun around this glowing knot like a whirlpool of smoke and fire. The tiny particles of dust that circled in the disk did not yet know their future. They were simply passengers in a storm, waiting for a shape. The glow in the center grew stronger, but it was uneven, flickering like a lantern behind layers of smoke. Sometimes the light pulsed out in sudden bursts. Streams of plasma shot upward and downward like spears, slicing through the dark and carrying with them magnetic force. Other times the light seemed to dim, as if the protostar was unsure whether it could hold its fire. Yet the pressure never stopped. The gravity of billions upon billions of tons of hydrogen and helium forced the atoms together, crushing them in a cage where there was no escape. And finally, after long ages of silence and flicker, the moment arrived. Hydrogen atoms that had always pushed away from each other were now trapped, so tightly that they could not resist. Protons collided, and in that collision they fused. One became another. Hydrogen turned into helium, and in that moment energy was born. Not the energy of falling rocks or spinning disks, but the energy of fusion, a chain reaction so powerful it could last billions of years. The protostar became something new. It became a star. The light it gave was no longer flicker, no longer unsure. It was steady now, steady and burning, though still wrapped in a veil of dust and gas. The fire, its heart pushed outward as fiercely as gravity pulled inward, and between those two forces, a balance formed. This balance was fragile at first, but then it held, and the star took its first true breath. And that star, friends, was our sun. Around it, the disk glowed with heat. The innermost rings were scorched bright, glowing like molten iron, while the outer rings remained cold, where ice crystals floated silently. From a distance, the disk looked like a glowing wheel, spinning endlessly, with the sun as its blazing hub. Most of the mass of the cloud had already been claimed by the sun. It took nearly everything for itself: hydrogen, helium, and the heavy metals forged by the ancient supernova. Almost 99.8% of the mass of the solar nebula was now locked inside that one brilliant furnace. Only the leftovers remained in the disk. Leftovers, yes, but these leftovers would soon become everything else: the planets, the moons, the comets, the asteroids, and Earth. But before that, the newborn sun had work to do. Its light and heat surged outward. Radiation pressure streamed into the disk, pushing the light gases farther away and sculpting the edges of the spinning wheel. Solar winds swept through, scattering the thin mist and clearing lanes in the gas. Some regions collapsed under their own gravity, forming knots that would one day be worlds. Other regions were blasted apart, too thin to ever hold shape. And in the quiet between these storms, dust particles clung to one another. They stuck together when static sparks passed between them. They bound together when icy coatings formed, softening their touch. Every collision made them bigger, heavier, stronger. The simple grains became pebbles, then rocks, then bodies, kilometers across. They drifted in wide orbits, crashing into each other, sometimes breaking apart, sometimes merging into something larger. These were the planetesimals, the children of the disk, and in one narrow orbit, not too close to the burning sun and not too far into the frozen dark, the seeds of Earth began to gather. But even now, danger remained. The sun was still young and violent. Its magnetic fields twisted and snapped, sending out bursts of plasma solar, flares that blasted the disk with lethal radiation. The newborn planets in progress trembled under that fire. Many of them did not survive, were swallowed, shattered, or ejected into the void. The early solar system was not peaceful. It was a battlefield. Yet through all this chaos, the balance held. The sun burned, the disk spun. Inside the disk, the materials continued to grow. The forces of gravity, pressure, and motion wrote a slow story that no one yet could read. A story of worlds that were still only promises. The promise was that one of those worlds would become Earth. The young sun blazed brighter now, sending its light to the edges of the disk. It had taken the energy of a supernova to begin this story, but now the sun no longer needed any other star. It had its own fire, a fire strong enough to burn for billions of years. Its light carved away the shadows, its heat gave form to the cold gas, and its gravity held everything in place. But the story was not finished. In fact, it had only begun. The disk still spun, the dust still clumped, the planetesimals still fought and grew. And among them, hidden in the endless collisions, a fragile beginning stirred. Would it survive the violence of the sun's rage? Would it last long enough to find water, to find air, to find life? No one could answer yet. But in the dark, there was a feeling, a question that echoed across the disk. Could this be the place where Earth will rise? The sun, newborn and brilliant, gave no answer. It only burned, and in the flicker of its fire, the future waited. The camera closes on the blazing sun at the center of the disk. Just beyond the glare, a swirl of dust gathers in a quiet orbit, forming a glowing knot. Whisper, almost like a heartbeat, can be felt in that swirl. A world is beginning. The first sign of Earth has appeared. The disk looks calm from far away, like a soft ring of fog around the newborn sun. But inside it, there is no calm. There is only traffic and pressure and quiet violence. Tiny grains flying in wide circles and then crashing into each other again. And again, and each small crash is a question with a sharp edge. Will they stick, or will they shatter? Will a world begin, or will a dream fall apart? And as the minutes pass, the crashes grow louder, and the clumps grow heavier, and the lines of dust turn into rivers. And somewhere on one of those rivers, a path appears where something big will be born, and no one can stop it now. Because gravity has decided to write, and gravity never lifts the pen once it starts to write. The newborn sun burned steady in the center, and its light pushed outward like a strong wind that never stopped, and around it the protoplanetary disk turned and turned. Thin near the center, and thick at the middle, and dusty at the edges. And the dust was not all the same. Some was rock, some was metal. Some was ice that formed tiny bright needles, and the grains were smaller than sand, smaller than smoke. But there were so many that they made their own weather. They drifted inward through the gas. They felt the drag like a hand on their backs, slow and steady, and as they drifted, they found each other. At first the meetings were gentle. 2 grains touched, stuck for a breath with a little static pull, then drifted apart, and then came together again with another friend. And a 3rd grain joined them, and a 4th, and soon the little groups were fuzzy like dust bunnies under a bed, light and fragile and easy to tear, but they were growing. The warmth from the sun coated some grains with thin films made from melted ice and simple molecules, sticky skins that made every touch last longer. And the clumps learned a new habit. When they bumped, they hugged. The disk was full of these tiny hugs. The clumps rolled in the gas like snowballs in a soft storm, and the bigger they became, the faster they fell inward. And that faster fall made them meet even more friends on the way, and so they grew. The traffic thickened, the gas swirled, and in that swirl there were places where the flows slowed and piled up, like leaves gathering in a corner of a stream, and the dust gathered there too. The clumps inside those pockets grew faster than anywhere else, because the pockets were quiet and rich and dense. From high above, the disk did not look smooth anymore. It showed rings and lanes and little vortices like the eyes of storms, and each eye was a trap for dust. 1,000,000 small traps filled a wide belt between the hot inner region and the cold outer rim. And in that belt, a border ran that would later get a name. The line where ice can live and ice must die, the snow line, and it mattered because ice made sticking easy, so just beyond that line, clumps jumped in size, and just inside it, clumps needed more time and more patience. Yet still they grew. Time passed, and the clumps that had been soft like dust bunnies became pebbles that could survive a stronger bump. And those pebbles became stones as wide as a hand, and the stones became rocks as wide as a room, and the rocks became boulders as wide as towers.
Ow.
And they learned new rules, rules of inertia and momentum and aim. When boulders hit, the sound. If space could carry sound, would have been like drums under the sea, deep and constant. Many hits failed. Fast strike would break both bodies into a spray of fragments that rained back into the gas. But the rain was not a loss, because the gas slowed the fragments and let them meet again with gentle hands, and the building kept going slow but stubborn. Sometimes a boulder grew so big that it began to pull on the dust around it. Not with a shout, but with a quiet tug that never stopped. And the dust felt that tug and curved its path and spiraled in, and the boulder fed on that spiral. A few of these hungry boulders crossed an invisible threshold. They reached sizes of 1 kilometer, and then 10, and then 100. At that size, the name changed. They were planetesimals, little planets, heavy enough that their own gravity helped them keep what they touched. They turned on their axes, some slow and some fast, and they cast thin wakes in the gas that curved behind them like tails. The disk had become a crowded schoolyard full of strong children who liked to run. Orbits crossed, paths tangled. The suns. Gravity held everyone in the big circle, but inside that circle there were many small races. And the racers bumped shoulders all the time. When two planetesimals met, they sometimes kissed and merged, and sometimes broke and bled rock. And sometimes one ripped a bite out of the other and kept going, leaving scars that would still be visible 4.5 billion years later if you knew where to look. There were places where the planetesimals learned to line up, not by choice, but because of the rhythm off the disk and the music of gravity. In those places, the strongest began to win more often than they lost. Each victory added mass, and mass made new victories easier. And this was the slow birth of oligarchs, the biggest bodies in each lane, the ones that swept their neighborhoods clean. They did not know they were kings, but they were, and their kingdoms widened with every loop around the sun. Heat followed the growth, and two large bodies merged, their speeds turned into fire, and that fire ran through their insides and softened the rock. And sometimes the metal melted and sank to the middle, and a center formed that was different from the crust. And this was the first quiet differentiation. A word that only means that heavy stuff goes down and light stuff floats up when things are hot and soft. Inside some planetesimals, little iron, hearts began to beat without sound. The newborn sun watched in its only way, with light and wind. It sent out gusts of particles that brushed the gas and drove it away from the inner lanes. And as the gas thinned, the small dust lost its soft cushion and could not slow crashes anymore. And the game changed, because when the gas is gone, the hits are harder, and the weak are broken, and the strong survive. The inner disk turned from a misty nursery to a stone yard, where steel rules matter more than kindness. In one lane, it's not too close to the sun's fire, and not too far into the cold, the dance found a special rhythm.
Ow, my belly.
Many and well-fed, and the oligarchs began to fight for space. One body, then another, grew 2 sizes as big as cities, and then as big as countries. And the pull they cast changed the orbits of hundreds of smaller neighbors. Some neighbors were slung outward, where they would wander for ages. Some were shaken inward and lost to the sun. Some were pulled into spirals that ended with a crash that added another skin of rock to the growing giant. The giant did not become smooth. It was a patchwork world, crater over crater, fresh scar over old scar. Hot lakes of melted stone spread between high raw mountains that had been thrown up in a single hour by a single strike. Each new impact boiled away any thin air that tried to gather. Each new rain of fragments raked the surface with fire. Still the body grew, because growth was the only way forward in that place. Farther out, in the cold lanes beyond the snow line, the story was different. There, the planetesimals were rich in ice as well as rock, and the oligarchs could grow even faster, because ice is more common and easy to grab, and soon some bodies were strong enough to pull gas directly, making envelopes that would one day become giant planets. Their gravity reached inward like a deep tide and shook the inner lanes. And some rocks in our special lane were thrown into new paths by those distant pulls, and every time that happened, another set of accidents followed, and every set of accidents meant more chances for one body to rule the lane. The lane we care about was crowded with these chances. The biggest body there? No, not Earth yet. It's not even a sure thing, yet gained a little edge, a small lead in mass. And that lead grew because every bit of mass helps you steal more, like a snowball that gets ahead of the other snowballs because it started on a steeper part of the hill. It ate its neighbors slowly, not with teeth, but with patience, 1,000,000 small meals and 1,000 big ones. It sent out a whisper of gravity that turned near misses into slow spirals, and slow spirals into gentle landings, and gentle landings into new layers. The sun's light drew a bright line across the disk, the inner region, baked and dry, made of metals and rock, and the outer region, cold and blue, made of ice and rock, and our lane sat near the warm side of that line. It's close enough to be dry, far enough to be safe, and that place would become a word in 100 languages, habitable. No one knew that yet, because no one existed to know it. But the physics cared, and the physics made a promise. Now the collisions grew rare, but larger. The small things were mostly gone, or were servants to the big ones, and the big ones stared at each other across long orbits. When they met, the world shook. 2 mountains of stone, the size of small moons, would touch at speeds so fast that stone would behave like water, flowing in waves, splashing in red sprays that cooled into glass. Sometimes the two would combine into one larger body with a new spin and a new tilt. Sometimes they would smash each other into clouds of shards that would later rain back down in weeks and months and make fields of broken glass that turned hot in the sun and then black at night. Our lane's champion grew through those trials. Inside, the heat from countless impacts and from the decay of short-lived elements kept the rock soft and the metal mobile. And iron flowed inward until it filled the center like a heavy bright drop, and stone rose above it like a sea, and a crust began to freeze at the top, only to be broken again and again by new strikes. Deep currents moved without sound, and the body learned to be round, because round is the shape gravity loves when there is enough mass. Not everything went the champion's way. A wandering body from a nearby lane swung through on a tilted path and tore a deep gash across one side, and for a while the champion lost mass in a storm of fragments. But the same gravity that let it lose also let it pull much of the storm back, and the pieces came home like comets with no tails. And the gash filled, and the surface smoothed, and the core grew another thin shell of iron. The sun changed too. It settled into a calmer, steadier light. Its winds dropped a little. The jets and flares still came, but less often. The inner disk thinned to almost nothing, and the gas that remained was to spread out to slow the big bodies anymore. The game was nearly over. The last points would be scored by a few final giant impacts, the kind that decide the tilt of axes and the spin of days and the fate of moons. And still there was dust. Not much, but enough to make a golden haze when you looked toward the sun. And that haze made halos around the growing planet every time the light came through at a shallow angle. And in that halo, the smallest stories continued, grains sticking to grains, sticking to pebbles, sticking to stones that would add the last thin coats to the larger story below. He was not there, and she was not there. But if a watcher had floated above the lane and timed the orbits and measured the masses and listened to the soft thunder that followed each meeting of giants, the watcher would have known what the numbers said. One body in this place had crossed the line from chance to certainty. It would be a world. It would keep almost everything that hit it. It would clear its path. It would become the anchor of this orbit. Night and day did not exist yet on that forming world, because it had no settled sky, only a hot glow through a smoky veil. Oceans did not exist yet, because water was still locked in stone and ice, or flying past on wild loops. Air did not exist yet, not in any way that would matter to lungs that would one day breathe. But weight existed, pull existed, shape existed, and destiny had taken its seat. The other oligarchs noticed in the only way they could. Their orbits bent a little when they passed, and their speed changed a little after each near miss. Some were lured closer by that small bend, and some were pushed away, and the pattern of those bends and pushes drew a picture that only gravity can understand. The picture said, here lies a center, here lies a future. Here lies a place where a blue world will stand. The last minutes of this chapter stretched long and hot. The champion moved through a field of boulders that had once been a rival, and as it moved, it gathered them like a slow tide gathering shells. And its surface flashed with 1,000 small fires that faded to red and then to black glass. Much larger rival, bright and bold, appeared at the far edge of the lane, its path crossing hours and months or years, and it shined through a pale light across the scarred face of the growing world. But that meeting belongs to another part of the story. 4. Now, the camera pulls close to the champion's horizon. The ground is cracked and glowing. Rivers of orange stone run between dark ridges. Over the rim of the world, the newborn sun burns like a white coin behind drifting soot. A thin shower of sparks falls from high above as the last fragments of a fresh collision rejoin their parent. And in the middle of that glow, the curve of the world is clean and round. A massive newborn planet stands where only dust had drifted before. It is not yet gentle, it is not yet blue. But it is there, heavy and sure, a promise with weight. Far across the lane, a shadowed giant body slips into a crossing orbit, silent and swift, its path already tied to ours by an old, invisible thread. The world that will be Earth shines red, and bright, and something large is coming. Imagine standing on the surface of a young world. But this is not the Earth, you know, not the Earth of oceans and skies, forests and cities. This is Earth before life, before calm, before hope. The ground shakes every hour as mountains rise and fall. The air is poison and fire, thick with choking smoke. Above, the sky is red with ash, torn open by flashes of molten meteors falling, like burning rain. The seas are not seas at all, but wide lakes of boiling lava, stretching for hundreds of miles, glowing and restless. Every horizon burns, and every silence breaks with another impact that turns night into day. This was Earth during its first age of time, so violent and terrible that scientists gave it a name from mythology. The Hadean Eon is the age of hell. But hidden inside this inferno was a secret. The first gift that would make life possible: water. The Earth had already taken its rough shape. After millions of years of collisions, one body had pulled more and more matter into itself, becoming heavy enough to be a true planet. Its surface was not solid. It was chaos, melted stone flowing like rivers, seas of magma glowing red and orange. Volcanoes taller than mountains we know today erupted again and again, spitting fountains of molten rock and gas into the air. The air itself was nothing like today's atmosphere. It was a thick, toxic mix of carbon dioxide, methane, ammonia, sulfur, and steam. To any living thing we can imagine, this world was poison. But there were no living things yet. It's only fire. Rock and fury. The Hadean Eon lasted from about 4.6 billion years ago to 4 billion years ago. For 600 million years, the young Earth was under constant attack. Huge planetesimals, the leftover children of the disk, slammed into its surface. Some were the size of mountains, some were as large as small worlds. Each impact unleashed unimaginable energy, enough to melt rock across continents, enough to boil away whole oceans of magma, enough to tear open the crust again and again. Some of these bodies carried more than just rock and metal. They carried something fragile, something cold water locked inside ice. When these icy comets and asteroids smashed into the molten Earth, the ice vaporized instantly, turning into steam that rose into the poisonous sky. At first, the steam escaped into space, blown away by the sun's winds. But the bombardments did not stop. Over millions of years, more and more water arrived. Steam gathered in the skies. Clouds thickened. And though the world was still a furnace, the water began to stay. Deep beneath the chaos, another story unfolded. The Earth was not only surface fire. Inside, the heat of impacts and the decay of radioactive elements melted the planet from within. Heavy elements like iron and nickel began to sink, slowly drifting downward through the molten layers, while lighter materials floated upward. This separation, called differentiation, built the layers of the planet, a dense metallic core at the center, a thick mantle above it, and a thinner crust on the surface. But the crust was weak. Impacts shattered it. Magma burst through cracks, resurfacing the planet again and again. If Earth had tried to look solid, space would have laughed, because every hour something came to break it apart. Still, the process mattered. Each cycle of melting and solidifying trapped more gases, more minerals, more of the ingredients for what would one day be oceans, continents, and air. The name Hadean was chosen for a reason. In Greek mythology, Hades was the lord of the underworld, the god of death and fire. This Earth deserved that name. It was hell in every direction: lava plains, glowing skies, boiling storms, and endless collisions. Imagine a single moment from this age. A rock 50 kilometers wide enters Earth's gravity, falling faster and faster. In less than an hour, it slams into the surface with the force of 100 million nuclear bombs. The crust melts for hundreds of miles around. Firestorms rage across the skies. Shockwaves circle the entire planet, flattening mountains that had risen only days before. And then, before the scars can cool, another body comes, and another, and another. Earth never rested. But here's the irony. This nightmare was building the foundation for life. Every impact delivered not only destruction but also resources, metals, carbon, and above all, water. The water boiled into steam, yes, but as the Earth cooled even slightly between bombardments, that steam condensed into rain. For the first time in its history, drops of liquid water fell upon Earth. The rain hissed and vanished on the hot rocks, but it did not stop falling. Over time, as more comets struck and more water arrived, the Earth began to change. By the end of the Hadean Eon, Earth was no longer just a ball of fire. Its core had formed, powering a magnetic field that shielded it from the harshest winds of the sun. Its mantle churned with molten rock, driving the first hints of tectonic motion. Its crust cooled enough to begin forming solid land. Most important of all, oceans began to appear. These oceans were not blue and calm like the ones we see today. They were dark, boiling seas, full of dissolved metals and minerals. They steamed under a poisonous sky, but they were liquid. And liquid water is the key to life. Yet even in this fragile beginning, danger never ended. The impacts slowed but did not vanish. One day, perhaps 100 million years after Earth first began, a shadow larger than any before appeared in the sky. It was they, a protoplanet the size of Mars, pulled by invisible strings of gravity into a collision course with Earth. The crash that followed would reshape everything, breaking Earth apart and fusing it back together, giving birth to the moon, and tilting Earth's axis forever. But that is the next chapter. The camera pulls back from the molten Earth, glowing red beneath a veil of steam and ash. Lightning cracks across the poisonous skies. In the distance, a massive shadow grows larger. And larger against the stars, the narrator whispers, "Another world is coming. And when it strikes, Earth will never be the same." Imagine standing on the young Earth. The ground beneath your feet is not solid. It trembles like a drum, cracked with rivers of molten fire. The sky above is red and black, filled with choking clouds of steam, ash, and lightning. Oceans are boiling cauldrons, shallow and violent, spraying steam that rises into endless storm clouds. And then, suddenly, the horizon brightens. Not with the sun, not with fire from Earth's volcanoes. Something else is coming. Shadow grows larger each passing minute. It's a world, a planet-sized body, rushing straight toward Earth. There is no escape, no shield, no mercy. This is the rogue protoplanet whose arrival will rip Earth apart, and in that destruction, give birth to one of the greatest mysteries of all time, the Moon. The Earth had survived 100 million years of chaos. Countless impacts had melted and remade its surface again and again. But nothing in the Hadean Eon compared to this. There was no mountain-sized asteroid. It was not a comet of ice and dust. It was massive, about the size of Mars, nearly a quarter the size of Earth itself. And once gravity pulled it into Earth's path, there was no turning back at first. The two worlds circled each other like predators, drawn closer by the pull of gravity. Thea's orbit had always been unstable, balanced on a razor's edge. Between the pull of Earth and the influence of other giants in the solar system, for millions of years it survived. But chance, chaos, and gravity always win in the end. They had drifted too close. The collision became inevitable. From space, the view was terrifying. Earth glowed red, a world of lava and fire. They spun silently, a younger, smaller planet with its own molten heart. As the two closed the gap, speeds reached tens of thousands of kilometers per hour. At such speeds, the impact would not be like two stones colliding. It would be like two oceans of fire colliding. Two titans smashing with energies beyond imagination. They struck Earth at a glancing angle. It was not a direct head-on crash. Strike tore across Earth's surface like a blade, gouging a wound deeper than mountains. Shockwaves circled the planet in seconds, cracking the crust and shattering continents that had barely begun to form. Lava exploded upward in fountains hundreds of kilometers high. Entire chunks of Earth's surface were ripped free, hurled into orbit as molten debris. The impact shook the core itself. Iron and nickel surged inward, joining Earth's growing heart. In one instant, the metallic cores of Earth and they fused together, creating a larger, denser core that powered Earth's magnetic field. Without this merging, Earth's shield might have been weaker, unable to protect life billions of years. Later, but the surface was destroyed. Whole layers of crust vaporized into glowing gas. The atmosphere boiled. Oceans of magma splashed into space, tearing free from gravity's grip. For days, perhaps weeks, the entire planet burned brighter. Then the sun itself, a world turned inside out. In orbit around Earth, chaos reigned. The debris from the impact formed a glowing ring of molten rock stretching thousands of kilometers wide. At first it was wild fragments colliding, shattering, scattering, but gravity has its own patience. Slowly, the fragments began to gather. Streams of molten stone circled together, drawn into knots. The knots merged into larger clumps. And in the silent darkness above the burning Earth, a new body began to form. That body was the Moon. It was not smooth and pale then. It was a molten sphere, glowing orange and red, still scarred by the violence of its birth. Over millions of years it cooled, its crust solidifying, its surface forming craters and basins. But its presence changed everything for Earth. The Moon became more than just a companion, became a stabilizer. Before the collision, Earth's spin was wild and unstable. The axis tilted and wobbled chaotically, shifting the planet's climate in violent swings. But the Moon's gravity changed that. By orbiting Earth, the Moon locked Earth's tilt at about 23.5 degrees, a tilt that gave Earth seasons. Gentle cycles of warmth and cold, summer and winter. Without this tilt, climates would have been extreme, chaotic, and hostile to life. With the Moon, the planet became balanced, its rhythm steady enough for life to eventually adapt and thrive. The Moon also gave Earth tides, its pull on Earth's. Oceans drew the waters back and forth in endless cycles. In the distant future, those tides would play a vital role in helping life spread from the oceans to the land, guiding evolution itself. Without tides, Earth's seas might have remained stagnant, its life forms trapped forever in the water. But the collision left other scars too. Earth's rotation was forever changed. Before Earth may have spun slowly. Earth spun much faster, a single day lasting only 5 or 6 hours. Over billions of years, the Moon's gravity slowed that spin, stretching days into the 24-hour cycle we know today. For hundreds of millions of years after the collision, the Earth and Moon remained closer than we see them now. From the young Earth's surface, the Moon filled half the sky, glowing like a blazing orange orb, lighting the night with a brightness that seemed unnatural. Slowly, it drifted farther away, inch by inch, until it reached its present distance. Even today, the Moon continues to move away. Just a few centimeters each year, the collision of Earth and HFY was not just an accident. It was a turning point. Without it, Earth would be unrecognizable. Without the Moon, there might have been no stable seasons, no tides, no balance for life to find its foothold. Some scientists believe life itself might never have begun on Earth without this single catastrophic event, but the story was not over. Earth was still a world of fire and storm. Volcanoes roared, skies thundered with poisonous gases, oceans boiled and hissed, and yet, slowly, the violence began to calm. Bombardments grew fewer. The surface cooled, the atmosphere thickened, and water brought by comets and asteroids began to settle not as steam, but as rain. For the first time, oceans spread across Earth's surface. Dark, endless seas filled the craters and valleys, steaming under the hot skies. It was still a hostile world, but it was no longer only fire. Now it was fire and water, chaos and calm, and hidden within those waters. Stirred by lightning and heat, the first building blocks of life were waiting to awaken. The camera drifts upward, showing Earth glowing red with lava, wrapped in thick clouds of steam. Above it, the newborn Moon shines, still molten, circling closer than ever. Its reflection glimmers faintly on the surface of boiling seas. The narrator whispers, the collision was over. The Moon had been born. But in the shadow of fire and stone, the oceans were stirring. And inside them, something unthinkable was about to begin. The storm never stopped. For millions of years, the skies above Earth were black and red, swirling with volcanic ash and poisonous steam. Lightning tore the heavens apart again and again, striking boiling oceans that hissed and fumed under the weight of clouds. The ground rumbled as volcanoes spat rivers of fire into the air. It looked like a world that could never know peace, a world chained to violence forever. But then, something small began to happen, something so quiet that no one could hear it. Raindrops. They fell, not once, not for a moment, but endlessly. The skies wept for thousands and thousands of years. Those tears became the first oceans. The age of fire was ending. The age of water was beginning. And inside those waters, something was waiting to be born. The Moon was still glowing faintly in the sky, molten from its birth, circling Earth far closer than today. Its pull tugged the seas back and forth, creating tides that churned the young waters. Below, Earth's surface was no longer only lava. Yes, volcanoes still raged, and impacts still scarred the crust, but slowly the planet began to cool. Air that once boiled away into space now began to cling. Trapped by Earth's gravity and protected by the growing shield of its magnetic field, this new atmosphere was not gentle. It was thick with steam, carbon dioxide, methane, sulfur dioxide, and ammonia. To us, it would be poison. To Earth, it was survival. The greenhouse gases kept the young planet warm, preventing the oceans from freezing as they formed. Volcanoes fed the skies with endless clouds, and those clouds condensed, falling as rain. It rained not for days, not for years, but for millions of years. Imagine standing on a high ridge in that time every horizon, dark with storm, the roar of endless thunder, the hiss of raindrops turning to steam on hot stone, and rivers carving new scars into the molten surface. The sound of rain would not be a song, but a war drum, beating for centuries without pause. And still the rain fell. Drop by drop, the craters and basins filled. Valleys became lakes. Lakes became seas. Seas became oceans. Slowly, the first great oceans of Earth spread out, covering much of the planet in dark water. For the first time, Earth was not only red and black, it was blue. The oceans were not like ours. They were hot, thick with dissolved minerals, bubbling with volcanic gases. The tides from the Moon churned them endlessly, mixing everything together. Lightning split the skies above, striking the waters and sparking reactions that would change the world deep below. Volcanic vents spewed superheated fluids rich with metals into the seas. Around these vents, strange chimneys of rock formed, filled with chemical gradients, hot on one side, cold on the other. Energy danced in these places, moving molecules back and forth, testing, breaking, remaking. No life existed yet, but the stage was set. The crust of Earth thickened. The lava seas cooled into solid rock, though cracks still split open with new eruptions. For the first time, continents, small, broken, shifting pieces of crust began to rise above the waters. They were bare, black, and jagged, with no soil, no plants, no breath of green. They stood like scars above the oceans, shaped by earthquakes and shattered by impacts. Yet they gave the young seas shores, boundaries where tides rose and fell, where water foamed and evaporated, leaving behind concentrated pools of chemicals. These shallow pools may have been the first laboratories of life, but Earth's skies were still alien. The air was heavy with carbon dioxide, making the planet's sky a sickly orange. Ammonia drifted through the storms, feeding lightning with more fire. Methane gave the air a strange haze, no breath to take. And yet all of these poisons were ingredients, building blocks waiting for something to use them. Over time, the greenhouse atmosphere kept Earth warm enough for liquid oceans to remain. The sun's radiation was fierce, but Earth had begun to shield itself. Deep inside, radioactive decay kept the mantle hot, driving tectonic movement. The liquid outer core churned, generating a magnetic field. That field stretched outward, protecting Earth from the solar winds that would have stripped away its air. But with it, Earth kept its skies, its waters, its chance for life. The oceans grew deeper. They absorbed vast amounts of carbon dioxide, pulling it from the atmosphere. This cooled the planet slightly, balancing the greenhouse effect. It was a delicate dance. Too much carbon dioxide and Earth would have boiled like Venus. Too little, and Earth would have frozen like Mars. But somehow, against all odds, the balance held. And within this balance, chemistry began its long work. Simple molecules formed in the seas. Hydrogen, carbon, nitrogen, and oxygen combined in endless variations. Some broke apart, some recombined, more complex. Energy from lightning, from volcanic heat, from the sun's radiation, drove these reactions forward. At first they were random, chaotic, without purpose. But slowly, order began to emerge. Molecules formed that could hold energy, molecules that could copy themselves, molecules that could change and adapt. It was not life yet, but it was the shadow of life, the whisper of what would come. Meanwhile, the Earth itself was changing. The days lengthened, from the 5-hour spin after Thea's impact to 7, then 8, then more. The moon's gravity was pulling at Earth's rotation, slowing it, stretching time. Longer days came gentler rhythms. The wild wobble of Earth's axis began to calm, steadied by the moon's constant pull. The planet was beginning to breathe. Everywhere, fire and water clashed. Volcanoes erupted beneath the seas, creating islands that quickly crumbled. Tides pounded the shores, carving cliffs. Storms raged across the oceans, stirring their depths. The planet was alive, not with creatures, but with motion, energy. Is simple but profound. How did life begin? No one can point to the exact moment. No one can say, here, on this day, the first cell was born. But we know the conditions were ready. The oceans were full of the right ingredients. Energy sources were everywhere: lightning, vents, tides. Time was endless, giving molecules millions of years to try, fail, try again. Perhaps it happened in the deep oceans near the hydrothermal vents. Perhaps it happened in shallow pools, where water evaporated and concentrated the chemicals. Perhaps it happened in both, or in ways we cannot yet imagine. Somewhere, somehow, the lifeless waters stirred, and the first fragile spark of life flickered into existence. The camera sinks deep beneath the waves of the young Earth. Volcanic vents glow like underwater torches, releasing streams of minerals into the dark seas. Lightning flashes above, faint even at this depth, but its energy pulses through the waters. Bubbles rise, Tiny molecules swirl, colliding, splitting, joining. And then, for the briefest moment, something strange appears. A molecule that does. Not break apart, a molecule that copies itself. The narrator whispers, "In the silence of boiling seas, a shadow moves. Not yet alive, but no longer dead." The first breath of life waits to be born. The oceans were restless. Storms thundered. Above, lightning splitting the skies, while underwater volcanoes spat endless heat into the dark. For millions of years, this cycle repeated, fire and water clashing, rain falling, tides churning. Nothing lived, nothing crawled, nothing swam. Yet in that silence, chemistry whispered. Tiny molecules formed, broke apart, and reformed over. And over? Most of them vanished as quickly as they came. But one day, deep in the boiling seas of the young Earth, a fragile molecule appeared that could do something no other had done before. It could copy itself. It was not yet alive, not yet a cell, but it was the first spark. And once that spark lit, it would never die. This was the first breath of life. The oceans of the Hadean had become vast cauldrons of chemistry. Dissolved minerals delivered by constant rain and volcanic vents swirled together with carbon, nitrogen, hydrogen, and oxygen. Energy from lightning and heat drove endless reactions. Most molecules were simple and fragile, breaking down almost as soon as they were formed. But some survived long enough to combine into chains. These chains could fold, twist, and interact in strange ways. And then, miracle of probability. One chain discovered a trick. When broken into pieces, those pieces could find their way back together, building a copy of the original. This was the dawn of replication. It may have been RNA, a simple cousin of DNA. Or perhaps it was something even simpler, a molecule lost to history. Whatever it was, it marked the beginning, because once molecules could copy themselves, they could compete. Some copied better than others. The oceans had become a battlefield of invisible wars. They gathered in bubbles of fat-like substances, membranes that formed naturally when certain molecules touched water. These bubbles provided protection, a little world within the larger sea. Inside, the fragile chains could survive longer, copy faster, and evolve new tricks. These bubbles were not yet true cells, but they were close protocells, the ancestors of everything alive today. From these beginnings, life's first breath stirred. The early cells were simple, nothing more than tiny bags of chemicals. They had no eyes, no mouths, no thoughts, but they had one ability that mattered more than all others. They could change. 8. Each mistake in copying created new versions. Some versions failed. Some succeeded. And across millions of years, the survivors became stronger, more complex. They clustered near volcanic vents, where hot fluids met cold water, providing the energy gradients they needed. They lived in darkness, but they thrived. And then came another miracle. Some cells discovered how to capture energy directly from the sun. These were the ancestors of cyanobacteria, tiny architects that invented photosynthesis. They used sunlight to split water, capturing its energy and releasing oxygen as waste. At first, the oxygen bubbled harmlessly into the seas. It reacted with iron dissolved in the water, forming bands of rust-red rock that still exist today, called banded iron formations. But eventually, the seas could hold no more. Oxygen began to rise into the skies. The Earth's atmosphere was changing. The arrival of oxygen was a double-edged sword. The early anaerobic cells, oxygen was poison. Many of them died, driven to the darkest corners of the ocean where oxygen could not reach. But for others, oxygen became power. Cells that could survive it, even use it, became stronger, more efficient, able to release more energy from food. This was the first great revolution of life, the oxygenation of Earth. The Earth itself responded. The skies that had once been orange with methane and carbon dioxide slowly turned blue. The protective ozone layer formed, shielding the surface from the sun's deadly radiation. For the first time, the surface of Earth became safer for life to move beyond the ocean's depths. The days were lengthening too. With the moon tugging at Earth's spin, days grew from 8 hours to 10, then 12, then longer. Tides continued their eternal pull, stirring the seas and mixing the oxygen-rich waters. The planet was finding a rhythm, a balance of day and night, tide and season, and within that rhythm, life grew stronger. But the story of life's first breath is not only survival, it is also connection. Each tiny cell lived alone, copying itself endlessly. But eventually, some discovered cooperation. Cells gathered in colonies, sharing food, protecting each other. They became more than the sum of their parts. It was the first hint of multicellularity, a whisper of the forests, animals, and humans yet to come. The young Earth was unrecognizable compared to today. Volcanoes still erupted, meteorites still fell, but now the world was not silent. It pulsed with invisible life, billions of tiny cells multiplying in the seas. From space, Earth glowed blue with oceans, white with clouds, and faintly green with the first microbial mats clinging to shorelines. Life had taken its first breath, and it would never stop breathing again. The camera drifts low over the oceans, showing strange mats of green-blue bacteria spreading across shallow waters, releasing streams of bubbles that rise toward the sky. High above, the clouds glow orange as the first oxygen begins to change the atmosphere. The narrator whispers, "Life had learned to breathe." And in doing so, it began to change the face of the entire planet. The age of fire was over, the age of life had begun. But this was only the first step. Greater transformations were yet to come. Billions of years had passed since that first explosion, the supernova that gave birth to the solar system. The Earth had survived chaos, fire, and ice. It had been torn apart by impacts, remade by volcanoes, washed clean by endless rains, and awakened by the breath of life itself. But the story was not finished. Even after life began, danger never ended. The Earth could still have failed. Could have become like Venus, burning under toxic clouds. It could have become like Mars, cold and lifeless. But it did not. Something rare happened here, something delicate and balanced. Something so improbable it feels like a miracle. Earth became a jewel of life in a universe of silence. The oxygen released by tiny cyanobacteria spread slowly at first, changing seas and skies. For millions of years, iron in the oceans drank it up, turning waters into rust-colored soup. The rocks of the seafloor soaked in oxygen until they could hold no more. Then, at last, oxygen began to fill the atmosphere. This was called the Great Oxidation Event. It transformed Earth forever. The orange skies of methane and carbon dioxide faded. Slowly, the heavens turned blue. High above, oxygen formed ozone, a protective shield that absorbed the sun's deadly ultraviolet rays. For the first time, the surface of Earth was safe from radiation. Life seized the opportunity. The simplest cells grew stronger, learning to use oxygen for energy. They multiplied faster, expanded farther. The oceans teemed with invisible battle cells dividing, competing, evolving. Some joined together in partnerships, cooperating instead of fighting. A new kind of complexity was rising. The continents shifted. Earth's crust was restless, broken into plates that floated on the mantle. They drifted across the planet, colliding and splitting, building mountains, digging trenches, opening seas. Land grew, broke apart, grew again. Each movement reshaped the face of the planet, creating new shores for life to explore. The moon, high above, pulled at the tides, churning the seas and guiding the cycles of life. Days lengthened further. What had once been only hours stretched into the 24-hour rhythm we know today. Earth's axis, tilted by Thea's great impact, brought seasons that changed the face of the world year after year. Summers, winters, rains, and droughts gave life challenges, and those challenges forced it to adapt, evolve, survive. Slowly, the oceans filled with strange new creatures. Tiny colonies of cells grew into the first multicellular beings. Soft-bodied animals drifted in the seas. Plants, still only simple algae, spread across shallow waters. Then, after billions of years, life made a daring move. It stepped onto land. The first plants crept across the bare rock, greening the countenance. They release more oxygen into the air, thickening the atmosphere, making it breathable. Insects followed, crawling across mossy stones. Amphibians dragged themselves from the seas, taking their first clumsy steps. Forests rose, dinosaurs roared, mammals appeared, and humans much later walked beneath the same sky, wondering how it all began, but stepped back. Look at the bigger picture. None of this was guaranteed. Every step in Earth's story could have gone wrong. If the sun had been a little hotter or colder, Earth might never have had liquid water. If Earth had been smaller, it could not have held an atmosphere. If Earth had been larger, its gravity might have crushed life under a thick blanket of gas. If they had not struck, there would be no moon to steady the planet's tilt, no seasons, no tides. If the atmosphere had trapped too much heat, Earth would have burned like Venus. If it had trapped too little, Earth would have frozen like Mars. Everything balanced, perfectly, delicately, probably. And so, Earth became rare. From space, it gleamed. A sphere of blue oceans, white clouds, green continents. Not a ball of fire, not a desert of ice, but a living world. A jewel, spinning silently in the darkness. The only planet, as far as we know, to carry forests and rivers, animals and people. Thought and memory, the Earth became more than stone and water. It became a cradle of life, a stage for history, a home for everything we are. And so, the great question returns. Who made Earth? Was it chance? The random outcome of physics and probability, matter colliding until a habitable world appeared? Was it destiny, written into the laws of the universe, that somewhere, somehow, life must emerge? Or was it something else, something we do not yet understand? The answer may never be fully known. But the evidence is here, written in stone, and water, air, and fire. The story of Earth is the story of survival, balance, and transformation. It is the story of a world that should not exist but does. Suspense ending final scene. The camera pulls back. First we see forests swaying, oceans glittering, cities glowing with human light. Then the view rises higher, showing Earth as a blue marble in the void. Beyond it, the silent stars stretch forever. Earth shines against that silence, fragile and small, yet alive. The narrator whispers, from fire, from water, from chaos, and chance Earth was born. A rare jewel in the universe. Perhaps, out there in the dark, other jewels wait to be found. But for now, this one is ours. Protect it.